Hello everyone, welcome back to kodEdge. In today's video, we are diving deep into the world of serverless computing with AWS Lambda and API Gateway. I will demonstrate how to set up an API Gateway with Lambda function using Terraform. Let's dive deep into the architecture. So this is a high-level architecture diagram. Here we are going to create a Lambda function. Then we will create a REST API in the API Gateway, and we will integrate it with the Lambda function. The end result will be user will fetch data serve from the Lambda function by sending post request exposed by the API gateway. We will also see how to set up resource-based policy, which will get used by API gateway to invoke the Lambda function using Terraform. Now let's jump into the hands-on. So first let me create a folder for the current lecture. So folder name I am giving as a lecture 6. And all configuration for today's lecture will be in the lecture 6 folder. So let me create a first file for defining the provider. So file name I am giving as a provider.tf. So how to define provider? So let's use the provider like this. Provider will be AWS, and in the resource block, let's provide the region. So region I am using as a AP-south-1. You can use any region as per your requirement. Now next step is to define the configuration for Lambda function and the API gateway. But before diving into the coding section, let's first see what are all configuration required in the AWS console. So let me open the AWS console and let's open the Lambda configuration. Let me click on the create function. So if you see in the basic information section, it requires function name, then runtime. So for our demonstration, I'm going to use runtime as a node.js 20.x version. Then there is an option for the architecture. And if you expand this execution role option here you can provide the execution role for the Lambda function. Okay. So same configuration we will provide from the Terraform code. So let me open the IntelliJ. So first let's create the Lambda function. So for that purpose, I am creating a new folder. Folder name I am giving as a Lambda. And in this folder, we will create the Lambda function. So I am creating a new file that will be index.js. And this is the code for the Lambda function. So here I am defining a simple method in which I am getting environment variable, that is video name. So I will show how to define this environment variable when we define the configuration for the Lambda function in the Terraform. Next, I am creating the response. So here I am defining status code as a 200. Then I have assigned the headers, content type equal to application/JSON. Here I am creating the body section for this response. So here I am creating one string, that is a message from, and I am concatenating this string with the environment variable. And here I am returning the response that I have created here from this function. Okay, so this is a very simple function. You can find this sample function from the AWS documentation as well. Now let's create a new file for defining the Terraform configuration. So let me create a new file. File name I am giving as a serverless.tf. So you can give any file name as per your requirement. So our first step is to create the Lambda function. So Lambda function required our index.js file in the zip format. Okay. So let's create the zip file using this index.js file. So for that purpose, let's use the keyword data. Then the data type will be archive file like this. And you can give name to the resource. So that will be lambda underscore zip underscore file. So you can give any name to your resource. Then in the block, let's define the type. So type will be zip. The next argument will be source file. So what is our source file? Our source file is index.js file that is in the Lambda directory. Let's define the directory lambda/index.js. And in which folder you want to create the zip file. Okay. So for that purpose, you can use the argument output path. And here you can define the output directory. So I'm using the same directory that will be lambda. In this directory, I want to create file with the same name, that is index.zip, like this. Okay, so this section will create the zip file for our index.js lambda function. Now next resource we will create for the IAM role. So resource type will be AWS IAM role. And let me give the name for the resource. So resource name I am giving as a Lambda role. Now let's understand what is the purpose of IAM role. So IAM role basically attaches necessary permission to the resource. In our case, that will be Lambda function. And by giving the permission, it will allow to access other services in the AWS. So here I am using argument as a assume role policy. And let me create a policy for the IAM role. So I am creating a new file for that. File name I am giving as a lambda-policy.json. And this is the policy for the IAM role. So if you see in the statement block, there is an action, that is STS assume role. So this defines the specific action that the principal is allowed to perform. So what is the principal here? Our principal is Lambda function. So in this case, it will allow Lambda service to assume the IAM role associated with this policy. Okay, so how to attach that policy? So let's see in the serverless.tf file. So let me first attach this file here. So you can use function file, that will be lambda-policy.json. Let me give name for the resource. So name I am giving as a same as a resource name. Okay, so here we have defined the IAM role. Now how to attach policy to this IAM role? So for that purpose, you can create the resource. Resource type will be AWS IAM role policy attachment. And resource name I am giving as a Lambda execution role attachment, like this. Now it has two arguments, that is policy ARN and the role. So role will be, let's copy this resource type, that is AWS IAM role dot resource name, that is Lambda role. And policy ARN will be like this. So here we are attaching AWS Lambda basic execution role to this IAM role. And this IAM role will get attached to the Lambda function. So you can attach multiple policy like this to this IAM role. Now let's get our actual resource, that is Lambda function. So let's use the keyword resource in AWS Lambda function. Let's give the name for the resource. So that will be YT Lambda function. Okay, so you can give any name to your resource. Then first argument is to give the function name. So here I am giving function name as a demo Lambda function. Next argument is to assign the file name. So what is the file name? So file name is lambda/index.zip file. The next is a role. So it got auto-populated because of the IntelliJ plugin. But normally it will be this resource type, that is AWS IAM role dot resource name, that is Lambda role dot ARN. Next is a handler. So what is handler? So if you go into the index.js, this is our handler, right? So let's use that name here as well, index.handler, like this. Then runtime, you can define runtime like this. Runtime will be node.js 20.x. Next argument to define the timeout for our function. So here I am defining timeout as 30. Now next argument is to define the hash for our Lambda function. So what is the purpose of source code hash? So let me write a line for this, then I will explain what is the purpose of source code hash. So you can use this resource type, that is data.archive file here, data.archive file like this. The name of the archive file, that is lambda zip file dot output base 64 SHA 256, like this. Now let's understand what is purpose of this source code hash. So this source code hash argument is going to generate hash for the zip file. So whenever you deploy this configuration, it will generate the new hash for the zip file. So let's say you have deployed this configuration and your Lambda function is running. Okay. Now let's say you want to do some changes in your Lambda function in the index.js file, and you want to deploy this new configuration. So what will happen when you define this argument? It will generate the new hash for your zip file. And based on this new hash, AWS will deploy the new Lambda function based on the code change. Okay, so that is the purpose of this source code hash. Now next argument is to define the environment variable. So in the code, if you see, we are using the video underscore name as an environment variable. Okay, so let's define this environment variable here. So you can use argument like environment, and in this block you can define the variables like this. So let's copy the environment variable name, and here I'm assigning some dummy string, that is lambda terraform demo. Okay, so lambda function configuration is ready. Now next configuration we will create for the API gateway. So let's write the next step, that is step 2, create API gateway. So before writing the code, let's understand what are all configuration required to create the API gateway. So let me open the AWS console and let's search for the API gateway. So here you can see multiple API types are available. So from here we are going to create REST API type. So let me click on the build, and here you can see option for creating the API. So it requires API name. So let me give the name, that is a test, and it requires the API endpoint type. So there are multiple types available. For our demonstration, I am going to use regional. Then if you create this API, next step is to create the resource in the API. Okay, so let me create the resource. So here you need to define the resource path and the resource name. So I am giving name as a demo for now, and let me create the resource. Now once you create the resource, it required to create the method, and the method, it required method type. Then there are multiple integration type. So for our case, it will be lambda function. Then you need to give the lambda function name and the region. So these are all steps we need to follow in the Terraform code as well. So let me open the IntelliJ. So first step was to create the API. So let's use the keyword resource. Then resource type will be AWS API Gateway REST API. Then let me give the name for the resource. So that will be YT API. Then let's give the name for our API. So I'm giving the same name, that is YT API. Let me give the description. So API for demo. Now next is to define the API endpoint type. So let me provide the argument, that will be endpoint configuration, and type will be regional. Okay. Now as we have created the API, next step is to create the resource in that API, right? So let's create the resource. Resource type will be AWS API Gateway resource. And this will be the name for the resource. Now it requires 3 arguments, that is parent ID, path part, and the REST API ID. So how to give the parent ID? So let's copy this resource type, that is AWS API Gateway REST API dot resource name, that is YT API dot root resource ID, like this. Now what is the path part? So if you see in the AWS console, let me click on the API. So here you can see we have given the path as a demo, right? So this path we need to define in that particular argument. So let me give path as a demo hyphen path. So you can give any path as per your requirement. Now next is a REST API ID. So let's copy this resource type, that is API Gateway REST API dot resource name, that is YT API dot ID. Okay, so second step is completed. We have created the resource. Now in this resource, we need to create the method. So let's use the keyword resource. Resource type will be AWS API Gateway method. So I am giving name for the resource as YT method. Now first option is for the authorization. So here I am giving authorization as a none. For authorization purpose, I am going to create a separate video, and in that video I will explain authorization using Cognito. Now HTTP method will be post. So you can use any method as per your requirement. So here I am using post for the demonstration purpose. Next is the resource ID. So you can get resource ID using this resource type, that is AWS API Gateway resource. Then resource name, that is YT API resource dot ID. Then what is the REST API ID? So we have already used here, just copy paste that ID. Now we have created the method of the type post. Now next step is to define the integration with the Lambda function. So let's create the new resource. Resource type will be AWS API Gateway integration. Let me give the name for the resource, that will be Lambda integration. So first argument is HTTP method. So we have already defined HTTP method in the API Gateway method. So let's use the same argument here. So let's copy this resource type dot resource name, that is YT method dot HTTP method. Then what will be the resource ID and the REST API ID? Just copy paste from this previous block. Next, what will be the type? So here I am using type as a AWS proxy. So what it will do? So whenever API gateway receive the response from the Lambda function, it will just directly forward that response back to the user. It will not do any customization in the response. So that is the purpose of this AWS proxy type. And if you use only AWS in the type section, in that case, you can customize the response received from the Lambda function and you can send that response back to the user. So I'm going to demonstrate that as well at the end of video. So let's use AWS proxy for now. Now next argument will be integration HTTP method. So it will be post. And the last argument will be URI of Lambda function. So let's use the resource type, that will be AWS Lambda function. Then the resource name, that is YT Lambda function. So we have already defined this configuration, right? Dot invoke ARN. Okay, so integration is ready. Now next step is to deploy this configuration in the deployment stage, right? So let's define the resource. Resource type will be AWS API Gateway deployment. Let me give the name for the resource. So first argument is to define the REST API ID. So we have already used that, just copy paste. Then stage name. So stage name I am giving as a dev. Now next argument is to define the triggers. So based on these triggers, it will do the redeployment of the configuration. So whenever API Gateway find any change in these resources like API Gateway method, API Gateway resources or API Gateway integration, in that case, it will do the redeployment of the configuration on the stage. Now next argument will be lifecycle. And here we will define this parameter, that is create before destroy equal to true. Now let's understand what is the purpose of this argument. So whenever Terraform detects any change that requires an update to a resource that doesn't support in-place modification, then Terraform will first destroy the existing resources. Then it will create a new resource with the updated configuration. But if you define this argument, that is create before destroy equal to true, in that case, what Terraform will do? Terraform will create a new resource with the updated configuration. Then it will destroy the existing resource. So what is the benefit of doing this? So it will minimize your downtime when deploying new updates to your API gateway configuration. Now next argument will be depends on. So what we want, our deployment resource should get created only after the creation of this API gateway integration resource. So we can add dependency for it. Just copy this resource type here dot resource name like this. Okay, so what will happen? It will first create this resource, that is API gateway integration. After that, it will create the API gateway deployment resource. Now, as our API gateway is going to invoke Lambda function, it is going to require permission to invoke the Lambda function. So let's define that permission. For that purpose, you can use the resource AWS Lambda permission. Let me give you the name for the resource, that will be API gateway Lambda permission. So what is the action here? Action will be invoke Lambda function, right? So Lambda colon invoke function. This is how you can write the action. Function name is AWS Lambda function dot resource name, that is YT Lambda function dot function name. Then what is the principle here? Who is going to invoke Lambda function? Lambda function is going to invoke by the API gateway. So that will be the principle. So this is how you can define the principal for the API gateway. The next argument will be statement ID. So statement ID will be this one, allow execution from the API gateway. And the last argument will be source ARN. So source ARN will be like this. So you are providing permission only to this YT API. So this is how you can create the resource-based policy for the Lambda function. Now next resource we will create for the output variable. So whenever you deploy configuration on the API gateway on the particular stage, it will give you invoke URL. And using that invoke URL, you can call the API. So let's define the output variable like this. Name I am giving as invoke URL. And how to get the value? Just copy this resource type, that is AWS API Gateway deployment dot resource name, that is API deployment dot what we want invoke URL. So this will show the invoke URL in the console because of this output keyword. So our configuration is ready now. So let me open the terminal. We will apply this configuration. So let me cd into the lecture 6 folder. And first command will be to initialize the provider. Okay, so our provider is initialized successfully. So let's apply the configuration. But before that, let's format our configuration. So let's use the command terraform fmt. Okay, so it has formatted the configuration. And let's use the command terraform apply. So it is showing some error for the incorrect attribute value type for this resource, that is AWS IAM role policy attachment. So let me see at line number 15. So in this resource, you can see we have not provided the name for the role. So let me reapply this configuration. Let me enter yes. Okay, so apply is complete and it has created the 9 resources. So let's copy this invoke URL and we will use this URL to call our API. So I'm using Talent for the testing purpose. You can use Postman or any other tool as per your requirement. So method type will be post and invoke URL will be this /demo path, because we have given the demo path as a path name. Here you can see message from Lambda Terraform demo. So this is a string that we have defined in the Lambda function, and this is the environment variable we have defined in the Terraform script. Okay. Now let's verify our configuration from the AWS console as well. So let's search for the Lambda. And here you can see demo Lambda function that we have created through the Terraform code. So package type is zip, runtime is nodejs.20.x. Let me open this function. Now here you can see API gateway. Now if you click on the code section, you can find the index.js file here. You can find the code. Now if you go into the configuration, you can see in the permissions section, it has attached the resource-based policy. So let me open this policy. So what is a policy? It is allowing this principal, that is API gateway, to invoke the Lambda function. And this is the resource ARN. So this policy we have defined in the Terraform. Let me open the Terraform code. So here if you see, we have defined the permission for the resource-based policy. You can see this is the resource we have defined for the creating the resource-based policy. Now next, if you see here, in the same permission tab, there is a execution role. And this is a Lambda role. Let me open this in the new tab. And it has attached the policy, that is AWS Lambda basic execution role, right? So from where this policy is coming from, so let me open the code. Now if you go in the IAM section here, so here we have attached that policy, that is AWS Lambda basic execution role. So because of this resource block, that policy is attached to the IAM role of the Lambda function. Now let's go into the API gateway. So let me change the region. So we are using region AP South 1. And this is the API we have created using Terraform. So this is a description for the API. Protocol will be the REST, and API endpoint type we have used regional. Then this is our resource, that is a demo path. And in this resource, we have created this method. So here you can see it has a method request, that is authorization is none. Then if you see in the integration request, integration type is Lambda. Region is AP South 1, and this is the Lambda function that we have attached, right? Then if you see integration response and the method response are blank because we have used the type as a AWS underscore proxy, right? Then let's go into the stages. And here you can find the stage name is dev. And this is the invoke URL that we got from the output variable in the IntelliJ console. Now let me go back into the resources and let me go into the method. Now here we are using integration response as a proxy integration. That means whatever the response it will get from the Lambda function, it will just forward that response back to the user. But what we want to do, we want to customize this response. Okay. So for that purpose, you can use this method response and integration response option from the AWS console. But we will do the same thing from the Terraform code. So let me open the IntelliJ. So let's go into the API Gateway section. And here first thing we will change, that will be the type. So type will be AWS. Okay. Then next, let's create the new resource. So let me add a step here. We want to do a custom response. And here, just create a new resource. Then resource type will be AWS API Gateway method response. Okay. So what we are doing here, we are creating this method response resource. So what will be the HTTP method? So just copy this resource type, that is API Gateway method dot resource name dot HTTP method. Let me give the name for the resource, that will be YT method response. Then what will be the resource ID? So let me copy this. Same for the REST API ID as well. Status code will be 200. Now next we will create the resource for the integration response. So let's use the keyword resource. Resource type will be AWS API Gateway integration response. And let me give the name for the response, that will be Lambda integration response. So what will be the HTTP method? Just copy this from the previous block. Then copy the rest of the argument as well. And for the status code, just copy this resource type dot resource name, that is YT method response dot status code, like this. Now we want to return the customized response from this block, right? So let's use the argument response template like this. So this is how you can define the custom response. So here I'm using response as application slash JSON. So in the JSON code, I am creating a Lambda value as a key. And to this key, I am assigning the response that we are getting from the Lambda function. Okay. So using this $input.path, and in the bracket, you can use the dollar. Using this, you can get the response from the Lambda function. And from this Lambda function response, I want to get the body, right? Then next, I am defining one more key, that is data. And to this data key, I am assigning dummy string, that is custom value. And now API Gateway will return this customized response whenever we call that API. Now next argument, we need to add the depends on. And this is also depend on the API Gateway integration. Okay. So what we did now, we just define these two resource. Okay. Now in the deployment section, if you see, we have defined the triggers. So just copy this resource type and just add it here. So resource type, then resource name dot ID. Next, we have added the AWS API Gateway integration response. So add that dependency as well. like this. Okay, so what will happen whenever it find any change in this particular resources, it will do the redeployment on this particular stage. Now let's apply this configuration. So let me first format our configuration, and let's apply this configuration using Terraform apply command. Let me enter yes. So let me open the AWS console and let me refresh it, and let me click on the method. And now if you go into the integration response, here you can find the response. So let me click on the edit, and if you click on the mapping template, here you can see the customized response that we have added through the Terraform code. And here in the method response, you can see it has returning the status code as a 200. Now if you click on the test, here as well you can test the API. So click on the test here. So you can see it is returning the customized message. So let's do the same thing from the talent API. So just call this API again. So here you can see we are getting the customized message from the API gateway. Now let's go back into the API gateway. And if you click on the demo path, here you can see option for the enabling CORS. So let's give the same option from the Terraform as well. So we will enable CORS from the Terraform script. So let me go into the IntelliJ. But before that, let me open this post method. And here in the integration response, you can see there is no header mapping. Same for the method response as well. So let me go into the IntelliJ. And in the API gateway method response, we will add the new argument that will be response parameter like this. So here we are allowing CORS. Next change we will require to do in the integration response as well. So argument will be like this, response parameter with this headers option. Okay, so let me apply this configuration again. Let me enter yes. Okay, so configuration is applied successfully. So let me go back into the AWS console. Let me refresh it. Let me go into the post method. In the integration response, you can see it has added the header mapping. Same for the method response as well. Okay, so this is how you can enable the CORS functionality. So that's it for this lecture. We have successfully set up API gateway with the Lambda function. And now once you're done with the practice, just use the command Terraform destroy to destroy all the resources. Okay, so thanks for watching the video.